Okay, today we're going to continue with hypothesis testing, and specifically, we're talking about z-tests today. This is section 8.2 in your book. All right, so yesterday's notes, we did talk about forming the null and alternative hypotheses. That was the first step of hypothesis testing. We did mention that there were 5 additional steps: finding the critical value, computing the test statistic, finding the p-value, making the decision, and summarizing the results. We will be going through all 6 steps today with the examples that we're looking at. So we are going to jump right into the first example. It says, a researcher reports that the average salary of assistant professors is more than $42,000. The sample of 30 assistant professors has a mean salary of $43,260. At alpha equal to 0.05, test the claim that assistant professors earn more than $42,000 per year. The standard deviation of the population is 5,230. Okay, so our very first step of hypothesis testing is to write out the null and alternative hypotheses. So if we look, the very first sentence says a researcher reports that the average salary of assistant professors is more than $42,000 a year. So that's what the researcher is thinking is going on. So if nothing's changing, we would expect assistant professors to earn $42,000 a year. If something is changing, this researcher is expecting that the salary is increasing. So mu is greater than 42,000. Okay, step number 2 of hypothesis testing is we want to find the critical value. So I'm going to draw out a normal curve. And if I really think that the salary of assistant professors is increasing, I would expect those values to fall on the right tail. So in this region, that's when I'm really going to start to say, okay, yes, maybe their salaries are increasing. The alpha value that is given in the prompt is going to go where the shaded region is. So the critical value is the z value that is associated with this line on the normal curve, or this area under the curve to the right that is equivalent to 5%. So we could look at the positive z chart and look up the left shaded region of 0.95, the closest we can get to that. Or you could actually look at the negative z chart and look up 5% on the negative z chart. But we should know that this value is going to be positive because it's on the right side. So take a look at that positive z chart or your negative z chart and find that critical value. That's a familiar number, 1.645. Okay, step number 3 of the process, we're going to find what is called the z-test statistic. So we're actually using the formula for the z-score from the central limit theorem section, which says we take the sample mean x bar minus the population mean mu and divide it by the standard deviation of the population sigma divided by the square root of the sample size n. So picking out the prompt values, the sample mean was 43,260. The population value was the value we used for the null and alternative hypothesis, 42,000. We're dividing that by the standard deviation, which was given in the prompt as 5,230, and dividing it by the square root of the sample size, which again was given as 30 in the prompt. Okay, we're going to go ahead and calculate this z value. Okay, I plugged those values into the calculator over here on the right, and I got a z value. I rounded that to 2 decimal places, 1.32. So guys, on my curve over here, if I take a look, I'm 1.32 standard deviations above the mean. So that means 1.32 is going to be in this region. It's in between the 0 and this 1.645 value. So that value is kind of close to the mean. That's in the typical sampling variability area. So it's not, it is higher than the mean, but it's not to this area where, ooh, we should really start to say, yes, their salaries are increasing. So we could right now make our decision for our hypothesis test when the test statistic does not fall in the critical region. The critical region is the area that I have shaded in purple. We do not reject the null hypothesis. Okay, so we're keeping with the idea that the mean is 42,000. If the test statistic or the test value, this 1.32, fell out here in the shaded region, then we would reject the null in support of the alternative hypothesis. To simplify things, we're going to find what's called the p-value using the calculator. So I'm going to go over to my calculator and push stat and over to tests. The very first one says z-tests. I'm going to highlight stats and enter the data from the prompt. So the mean of the population was 42,000. The standard deviation was given as 5,230. The sample mean was 43,260. And n was 30. This next line is indicating which one we have for the alternative hypothesis. We picked the greater than case. That is the last symbol in that menu. And calculate. Okay, so we notice that it does give me that z value that we just calculated by hand a second ago, 1.32. But the next line says the p-value is 0.09. So that means the probability that I would get a value this far from the mean or further is 0.09, 9%. I only want to reject if it's the alpha value or less. So again, this supports my decision when the p-value is 0.09. This supports my decision to do not reject the null hypothesis. If I'm not rejecting, that means I'm keeping it. Okay, I'm going to erase this slide, guys. The last step is the summary. I don't really have enough space to write it. And actually, maybe I'll just say it. At alpha equal to 0.05, there is not enough evidence to say that the average salary of... Okay, the next example says the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is $25,226. The standard deviation of the population is 3,251. At alpha equal to 0.01, can it be concluded that the average cost of stroke rehab at a particular hospital is different from 24,672? Okay, so first step is we're going to write the ho and the ha, the null and alternative hypothesis. So the null, the mean of the population was 24,672. The researcher is questioning whether it's different at this particular hospital. So that would be the not equal to case. We don't want to just pick greater than or less than because before the sample was collected, we really didn't know what was going on with that value. Okay, step number 2, we want to find the critical value. So for this one, I'm not sure if it's increasing or if it's decreasing. So I'm going to cover both bases. I'm going to shade both sides. But when this happens with an alpha value of 0.01 and you're shading both sides, you have to split the alpha between the two tails. So if I split the 0.01 between the two sides, I would have 0.005 on the left and 0.005 on the right. We need to find both of those critical values. So we have two critical regions. So if we look up 0.005 on the negative Z chart or 0.995 on the positive Z chart, we're going to get critical values of positive or negative 2.575. Again, hopefully that's a familiar number from confidence intervals. Okay, step number 3, we're going to go ahead and calculate the Z-test statistic. So from the prompt, the sample mean was 25,226. The population mean was the value used for the null and alternative, 24,672, divided by the standard deviation of 3,251, divided by the square root of the sample size. For this one was 35. At this point, guys, I'm going to go straight to the calculator and plug in those values into stat, over to tests, and again, the very first one, Z-tests. Okay, I plugged those values into the calculator. The null hypothesis was 24,672, the standard deviation 3,251, the sample mean 25,226, the sample size 35, and I selected the not equal to alternative. We're going to calculate that. It's going to give me the test statistic, which Z equals 1.01. And then also the p-value. So step number 4, the p-value is 0.3133. If I go ahead and mark these on the curve, we can see that 1.01, it's in between negative 2.575 and positive 2.575. It is a positive value, so I'm going to stick it over here on the right. So that's where my test statistic falls. My probability that that would happen, I would get a value that large or larger, is 0.3133. We see that that is bigger than the alpha value. So again, I am going to do not reject the null hypothesis. Okay, so if I'm not rejecting, that means I'm keeping this idea. I am not supporting that the mean is changing. So my conclusion, my summary statement, I would write out at alpha equal to 0.01, there is not enough evidence to conclude that the cost of rehabilitation for stroke victims is different than the $24,672.